Assalamualaikum and hi! So in case you didn't recognize me, I am Iza. So today, in this video, me and my groupmates will be presenting a problem solution to a problem statement that was given to us as an assignment to our course, which is MBT 1 and 3. So without further ado, let's get started.
Assalamualaikum and hi! My name is Siti Zulaikha binti Muhammad Fitri and I am from CS1121C Group 6. So, for today, I will be presenting the introduction. So, everyone must be wondering, what is related rate? Here I am to explain. Related rates is actually an application of implicit differentiation which involve finding a rate at which the quantity changes and relating to other quantities which the rate of change is unknown. But don't worry, the rate of change usually related to the time. Related rate is actually quite simple. If we know how the variables are related and how fast one of them changes, we can actually calculate how fast the other one variable changes. All we need to do is just write an equation that relating the two variables and find the derivative respect to the time, dx over dt. For example, look at this picture. If we look at this picture, we can see that the water level in the cylinder increases as the time running. This also means that the volume of the water will also be changing respect to the time. If we want to observe the rates of change of the water level height and the rates of change of the water volume with respect to the time, we need to apply the related rates concept. So we can assume the height of the water level as h and the rate of change as dh over dt, while the volume of the water as V and the rate of change of the volume of the water as dV over dt. Next, these two rates, dH over dt and dV over dt, can be used to determine unknown quantity or values depends on the question. So, after I explained about the cylinder, you guys must already understand about basic related rates. Congratulations! Now, let me tell you guys strategy for solving related rates problems. First step, identify the rates of change that are known and the rate of change that we need to find. Step 2, find an equation or formula that relates the variables whose rates of change were identified in step 1. Step 3, differentiate both sides of the equation with respect to time. Next, after completing step 3, substitute all known values for the rates of change and the variables and then solve for the unknown rate of change. And you will get your answer. Bingo!
Next is the applications of related rates in real life. So the first example is a balloon being filled with air. So when a balloon is being filled with air, the volume of the balloon will increase as well as the radius of the balloon increases. Next is the ladder sliding down a vertical wall. So when the ladder slides down, the horizontal distance will decrease while the vertical distance will increase. The last example is a stone creating a circular ripple in a lake. When a stone is dropped into a lake, it will create a circular ripple. So the area of the circular ripple will increase as well as the radius of the circle. There are a few importance of related rates in real life. So first of all, it takes advantage of quantities that are related to each other. Next, it involves two or more quantities and their corresponding rates of change with respect to time. It also helps to determine how fast or how slow a certain quantity is changing.
Hi, my name is Abdullah bin AZMAN and I will be presenting writing the problem statement and the problem solution. So this is the problem that we need to solve. An airplane flying at 450 kilometers per hour at a constant altitude of 5 kilometers is approaching a camera mounted on the ground. Let theta be the angle of the elevation above the ground which camera is pointing. When the theta equals to pi over 3, how fast does the camera have to rotate in order to keep the plane in view? So this is a picture to make us easily imagine the question. We assume the adjacent as x and the angle as theta, which is given in the question as pi over 3. State in the question that the airplane flying at the 450 kilometers per hour, which is we can assume as dx over dt. The adjacent is x so far. After we differentiate it with respect to time, we can get dx over dt equals to negative 450 kilometers per hour. But why it is negative? When the airplane moving forward, approaching the camera, the angle between the angle will become smaller. When the angle becomes smaller, we need to put the negative sign to show that the rate is decreased. From the question, we know that the altitude is constant, which is 5 kilometers. From the airplane to the ground, we can assume this is the opposite of the theta. So the question asks us to find how fast the camera has to rotate in order to keep the plane in view. So we actually need to find d theta over dt to answer this question. So first things first, we need to use the trigonometry method. To find the x or adjacent, we must use TOA method, which is tan theta equals to the opposite over adjacent. The opposite is 5 km and the x is unknown. To find x, submit the theta given in the formula, which is tan pi over 3 equal to 5 over x, and we move x to the left side and we bring the tan pi over 3 into the right side and we get 5 over square root 3. So we get the value of x now. So but we still don't get the d theta over dt value. So what we need to do, we make the equation of the tan theta equal to 5 over x and we differentiate the whole equation. The equation after differentiate is secant theta square d theta over dt equals to negative 5x power of negative 2 dx over dt. We already get the value of x and dx over dt. Put the value into the equation to solve the equation, which is 1 over cos pi over 3 square d theta over dt equals to negative 5 in bracket 5 over square root 3 power of negative 2 times negative 450. We will get 4 d theta over dt equals to 270. So now we want to find the d theta over dt. So we need to move this 4 into the right side. So we move and 270 will be divided by 4 and the final answer for d theta over dt we will get 67.5 radian per hour. We will already answer the question, which is how fast does the camera have to rotate in order to keep the plane in view, which is 67.5 radian per hour. That's all from me. Thank you.
In conclusion, the keys to solve a related race problem is by identifying the variables that are changing and then find a formula that connects the two variables to each other. Implicit differentiation techniques are used to solve for the unknown rates of change. And lastly, related race application can be used to answer a focusing problem as well as the elevation problem. So in this case, how fast the camera has to rotate in order to give the aeroplane in view. I think that is all from us. Thank you for taking the time to watch our video. We hope you enjoyed the video as well as understand the problem solution that we came up. Till we meet again, Assalamualaikum and bye!